Hello to your grade 12s. Today I want us to look at projectile motion. We have a question here which is very useful, which is very highly guaranteed that it could pop up in your exams, in your June exams, September trials, as well as the final examination in November. So let's pay attention on this one. So in this question example, we're going to be discussing fundamentally the projectile motion questions that are highly asked in your examinations. So the question says there, okay, so we have a statement there which says ball A is thrown vertical upwards from the bottom of the building, with which is 8 meters high with a speed of 50 meters per second. After 0.5 seconds, ball B is also thrown vertically upwards from the top of the building. Both balls reach a maximum height at a point P at the same time as shown in diagram below. So this is our diagram. So ignore the effects of air friction. Let's just ignore those. Okay, so the very first question says define the term projectile motion. So we have to define the term projectile motion. So what is projectile motion? Everyone knows that when you talk about projectile motion, we talk about an object. So projectile motion. So the definition of the term is that these are the objects, or this is the object that is in motion. Okay, the object that is in motion under the influence of gravity, or let's say whereby the only force that is acting on it is gravity, which is gravitational force. So projectile motion is the motion of an object of which the only force acting on it is gravitational force. Okay, yes, gravitational force. Okay, so that is gravitational force. Okay, so that's how it goes. Let's move to number 2. So number 2 says the time taken by ball A to return to the ground. All right, so ball A is projected vertically upward. So I mean that is thrown vertically upwards at 50 meters per second, which is our initial velocity. So we have to calculate the time at which the time taken by the ball A to return to the ground. So it was projected upwards up until to this maximum height, then back to the ground. So we have to calculate the time taken by that ball to move that path. Okay, all right. So here it's very clear that we know that as we know the initial velocity, right? So we know the initial velocity. We know the initial velocity, which is 15 meters per second. We know the final velocity because when you project the ball upwards, when you throw the ball upwards, at some point it's going to stop at the maximum height, meaning that the velocity there is 0. So our final velocity is going to be 0. We know the final velocity. So the acceleration, which is 9.8 meters per second squared. Okay, yeah. All right. So we don't know the change in y. Okay, vertically. We don't know. So what about change in time? We're looking for change in time. Okay, yes, we're looking for change in time. So we don't know this, we're just looking for change in time. All right, so let's look in our equation of motion. So by we're going to have change in time, the acceleration, the final velocity was the initial velocity. All right, so which one you can use there? All right, let's try to use the simple one, which is Vf is equals to Vi plus A change in time. All right, so in this case we know that the final velocity is 0, which is equals to the initial velocity, which is 15 meters per second. All right, in this case, let's choose upward as positive, okay? Let's choose upward as positive, plus acceleration. The acceleration, the gravitational acceleration is acting downwards, so it's going to be negative because upward is chosen as positive. So that's going to be negative 9.8 meters per second squared multiplied by change in time. Okay, yes, multiplied by change in time. All right, look now, let's solve the problem. So we are going to take our 15 to that side, it's going to be negative 15. So minus 9.8 change in time. Okay, so divide by 9.8 to divide by negative 9.8. So this cancels that. We'll have to change in time, which is going to be equal to negative 15 divided by negative 9.8. Let's just those in our calculators. So negative 15 divided by negative 9.8, and your final answer there will be 1.53. Okay, 1.53 seconds. 1.53 seconds. That's how it goes. I hope everyone can see. Oh, everyone didn't see at that point. I'm so sorry. So that's going to be change in time, which is equals to 1.53 seconds. All right, remember the question says there, the question there said the time taken by ball A to return to the ground. Remember now that we just calculated the time whereby the ball went up until to the maximum height. So the pathway is the same, so mean that also the time when it comes back to the ground is going to be the same. So we're going to multiply this by 2, which is going to be equals to 1.53 multiplied by 2. That's going to be 3.06 seconds, and that's how it goes. And that's it. That's how it goes. Yeah. So the time taken there is 3.06 seconds for that ball to return to the ground. That's how it goes. I hope everyone understands. All right. So let's move to that was 2.1. So sorry, number 2.1. Let's move to 2.2. Let's move to 2.2. So sorry. Let me just do like this. All right. Hope everyone can see. Okay. All right. So 2.2 says the speed at which ball B is thrown upwards. So I have to calculate now the speed at which ball B is thrown upwards. All right. Ball B is that ball that is on the roof there, and the edge of the roof, thrown upwards up until the maximum height. All right. So we have to calculate its speed. All right. We know its final final velocity, which is 0. We don't know the initial velocity, mean that we are required to calculate the initial velocity there. All right. So at maximum height, the velocity of ball B at P is equals to 0, which is final velocity. All right. The time taken by that ball is 0.5. Okay. All right. After that ball was projected after 0.5 seconds. Was projected after 0.5 seconds, right? Yes, after the ball A was projected upwards. I hope you understand or you remember that one, okay? Yeah. Okay, so in this case now, what are you going to do? In this case, we're going to take the time taken by the ball A from the ground up until to the maximum height, because those balls landed at the maximum height at the very same time. Okay, all right. So I mean that after 0.5 seconds, the time taken by both balls were the same. So we're going to subtract the time taken by this ball B from the edge of the roof to the maximum height, and subtract that from the time taken by ball A from the ground up until to the maximum height. I hope everyone understands it. All right, so at 2.2, we're just going to simple do that. Okay, yeah. Okay, so ball A took 1,53 seconds from the ground up until to the maximum height. So that's going to be 1,53 seconds minus 0,5 seconds, which is going to be equals to 1,53 minus 0,5. That's going to be equals to 1,03 seconds. That's how it goes. So that ball B, to reach its maximum height, it took 0,3 seconds. Okay, yeah, 0,3 seconds. Hope everyone can see. Okay, took 0,53 seconds. Yeah, all right. Let me just move like this. Took 0,53 seconds. Hope everyone can see. Okay. All right. So now the speed. We know the time. Okay. We know the time, change in time. We know the change in time. We know the final velocity, VF. We don't know the initial velocity you're looking for. We know the acceleration, okay, obviously. All right, so we don't know the change in y, the distance from the edge of the building to the maximum height. We don't know. All right, so let's look for this, okay, for this projectile, for this equation, okay, that's going to be appropriate to be able to calculate 2.2. All right, so at 2.2, we know the time, which is 1,03 seconds. All right, so let's use final velocity is equals to VI plus A, change in time. All right, so 0 is equals to initial velocity we're looking for plus acceleration, which is negative 9,8. Remember that we take up as positive, multiplied by change in time. Change in time is 1,03 seconds. All right, let's do that right now. So negative 9,8 multiplied by 1,03, that's going to be equals to negative 10, so that's going to be equals 0 is equals to VI plus, so sorry, negative 10,094. So in this case, we take negative VI, which is going to be equals to negative 10,094 meters per second, and therefore our initial velocity there for that ball be projected upwards. Oh, everyone can see. Okay, everyone can see. All right. Okay, so that's going to be 10,094 meters per second. That's how it goes. And that's it. Very correct. And that's our final answer at 2.2. Let's move now to 2.3. Question 2.3. So question 2.3 asks us to calculate the height of building H. Okay, the height. Okay, H there. All right. So in this case, let me just remember that we calculate the height. Okay, we're calculating the height H there. Let's just move this way. Yes. Okay, and the height. Okay, I'm just going to calculate it on this side. Let's just say like this. The height 2.3, 2.3, the height there. All right. Okay. All right. Remember, we know the time it took for ball A from the ground up until the maximum height. Okay, from the ground up until to the maximum height. And we know the time it took from ball B to the maximum height also. So in that case, we should first calculate the distance from the ground up until to the maximum height at P. After that, we subtract that distance. After that, we also calculate the distance from the edge of the building, from the top of the building up until the maximum height, and we subtract that distance, which is traveled by ball B from the edge of the building up until to the maximum height, from this distance of ball A from the ground up until to the maximum height. Hope everyone understands. Here, what I'm trying to say is that from the ground up until to point P, from the ground up until to point P, that's going to be our distance D, the whole distance up until to the maximum height. And from the edge of the building up until to, let's say also this is our distance, okay, traveled by ball B. Then what are we going to take? We're going to subtract that distance traveled by ball B so that you can get this distance here, this distance, okay? Yes. So let's first calculate the distance from traveled by ball A up until the maximum height, okay? Let's say like this, okay? All right. All right, so 2.3. All right, so calculating that distance there. So which formula we should use? Let's use this one. So because we know the final velocities of the initial velocity, Vf squared is equals to Vi squared plus 2a change in y. All right, let's use this one. So Vf squared is 0 squared is equals to initial velocity, which is we're taking upwards as positive. So in this case, what we're going to do, we're going to substitute 15 squared plus 2 negative 9,8 change in y. All right, hope we are still together. So this is going to be 0 is equals to 2 to 5, right? So 15 squared is 225. 225, that's going to be minus 19,6 change in y. So we take that one to that side to become negative 225. 225 is equals to negative 19,6 change in y. So we divide by negative 19,6 divide by negative 19,6. This cancels that. We'll have to change in y, and therefore our change in y will be equals to negative 225 divided by negative 19,6, and the answer will be 11,48 meters. That's how it goes, 2.3. So we just calculated the distance from the ground up until to the maximum height, and now let's calculate this distance, okay, this one here, so that we can subtract it so that we can get the total distance of the building. Okay, all right. So in that case, let's calculate for ball B from the edge of the building up until to the maximum height. All right, so so the initial velocity there, we know the initial velocity. We also know the final velocity. You can also use the very same, okay, the very same. Yeah, you can also use the very same, but let's just use this one. Change in y is equals to Vi plus, because we also know the time. Yeah, we also know the time plus okay, so Vi change in time, so sorry, Vi change in time plus half a change in time squared. All right, so change in y will be equals to, so our change in y will be equals to, initial velocity was 10,09. Remember that you're taking upward is positive, so that's going to be 10,09 for change in time. Change in time is 1,03 seconds, right? Yeah, 1,03 seconds plus half negative 9,8 change in time squared 1,0, so sorry, 10, that's going to be 10,094 squared. All right, hope everyone can see there. So our change in y, that will be equals to, let's punch all of that in our calculator. So 10,094 multiplied by 1,03 plus half negative 9,8 1,094 squared. And the final answer there for me is 4,53. It's 4,53, okay, meters. All right, so now let's take this 4,53 meters and minus it from 11,48. So our change in y there, therefore our change in y will be equals to 11,48 minus 4,53 meters. Alright, so the final answer will be equals to 11,48 minus 4,53. That's going to be equals to 6,95. 6,95. It's going to 6,95 meters, and that's how it goes. Alright, I hope I rounded off correctly. Then let's check again. So 10,094 multiplied by 1,03 plus half negative 9,8 multiplied by 10,94 squared. 0.94, so sorry, 0.94 squared. Okay, yes, so that's the final answer there, I believe, to 6,95 meters, and that's how it goes. All right, so now so the following question says, how does the velocity of ball A compare to that of ball B at the instant when the two balls hit the ground? All right, okay. Alright, so the correct answer there, let me punch again. So 10,094 1,03 plus half negative 9,8 multiplied by 1,03 squared. Okay, all right, so it's 5,19841, okay, because I've been doubting this. Okay, so it's 5, so the correct answer there is 5,19841. Let's round it off now, which is going to be 5, let's pour there, so it gives 1, so it's going to be 20. That's how it goes. Okay, yes, so it's 5,20 meters. So 5,20 meters. So the final answer there will be equals to, let's say 11. Hope everyone can see. Ooh, not everyone can see. Okay. Alright, I've been making these mistakes, so you can see, guys, so sorry about that. So minus 5,20. So the final answer there will be equals to 6,28 meters, and that's our final and correct answer. I'm very confident about this answer. It's very correct. Alright, so now let's move to the following question. Alright, the following question says, how does the velocity of ball A, so that's 2.4, let's just write here 2.4. Okay, 2.4. What 2.4 says, 2.4 says, how does the velocity of ball A compared to that of ball B at the instant when the two balls hit the ground? Give a reason for your answer. Okay, so the velocity of these balls when thrown upwards and they meet at the maximum height and they fall down again up until to the ground, it will be the same. The velocity will be the same. So the velocity will be the same. The reason will be that both balls fall under the influence of gravity, meaning there is no other ball that is thrown. Both balls went to the maximum height and fell back to the ground, so there was no ball that was being thrown or exerted any kind of force downwards. Okay, yeah, I mean that the initial velocity was the same, which is 0. That's how it goes. All right, let's move to the next following question. The next following question says, on the same set of axes, and we take another paper there. Okay, so it says that on the same set of axes, sketch the velocity time graph for the motion of the balls A and B from the moment they are thrown vertically upwards until they reach the ground. Okay, until they reach the ground. All right, let's just write here as number 3 so that you can draw it. Okay, just going to use the whole paper there. I'm not going to be on scale, please forgive me guys. So this is going to be our velocity time graph for both balls. Velocity time graph for both balls. Okay, so this is velocity, which is meters per second, and this is our time, which is in seconds. So sorry, time in seconds. All right, so in this case, how do we do that? Remember that ball A was being thrown upwards, okay, at 15 meters per second. Ball A thrown upward at 15 meters per second at 0 seconds, right? Yeah, 0 seconds. But now ball B was also thrown upwards just after 0.5 seconds. This ball has been thrown upwards. So let's say here, we have 0.5 seconds, say 0.5 seconds, and say let's move towards ball B. So this is for ball A, and this one is going to be for ball B. Okay, so for ball B, so sorry, ball B is not going to start here, it's going to start here. Okay, yes, so thrown, okay, yes, up until that was 1.53 seconds, right? 1.53 seconds up until the maximum height, whereby the velocity of both balls were 0. All right, so after that, let's move towards then they fall back to the ground. At what time? At 3 comma something, 3.06 seconds, 3.06 at 3.06 seconds. All right, not going to be on scale guys, I'm so sorry about that. So let's just say minus 15 there up until they reach the ground, and that's how it goes. So for the marks here, the velocity time graph, you can just write here velocity time graph, velocity time graph. So for the marks, how many marks? I think that's going to be around 4 to 5 marks, but the shape of the shape of the graph is going to be a mark awarded, let's say 4 marks, 15 meters per second. Also here the starting point, as well as the ending time. Okay, yes, so let's just say 5 marks in that case, and that's how it goes. Okay, yeah, so that's it guys, continue to practice. Have a great one. Cheers, bye.